Here we go. We have a question. Recover a tree from pre-order traversal. So this is a hard level question. We have given a pre-order DFS on the root of a binary tree. At each node in this traversal, we output D dashes where D is the depth. Then we output the value of this node. If the depth of a node is D, the depth of its intermediate child is D plus 1. We know what a node and what is its child. So the depth of a root node is 0. We know if a node has only one children, then that children is guaranteed to be left child, and we need to return a tree. So suppose we have given this string. So in this string, 1 is our root node, is it single value, then 1 dash. So this is the left children of the root node with depth 1, the value is 2. With the depth 2, the value is 3. With depth 2, we have already created one value, so this is the right children. Then with depth 1, we have another value. We have another node, its value is 5. We have already created left, so this is the right one. Then on the left we have 6, on the right we have 7. So that's how this will work. And then we have this example, then we have this example. So let me first copy this example. So now let's build the approach. So we have given this string, and using this string, this is the string. Then we need to create a tree. So this is the pre-order. Then how we gonna create a tree? First of all, find the root node. We find the root node. Now let's just create it. Then we have a single dash. So after single dash, we know the depth. So depth is 1. Then we find the value. Value will be 2. So we have iterated till here. So we know the depth, we know the value. Then we iterate in the root node. Then create this value. Then we have 2. So this is the second. Then after the 2 depth, we have a value as 3. So 1 depth, then 2 depth, we have a value 3. Then again 2 depth, and we have a value 4. So again 2 depth, and we have a value 4. So this is 1 depth, this is 2 depth, but the left is already created, so we're gonna create right. Then we have 1. So 1, this is already created. So after the 1 depth, we have a value 5. 1 depth, we have a value 5. But this on this side we have already created, so this is the right one. Then after the 2 depth, we have a value 6. So after the 2 depth, we have a value 6, it is already created. After the 2 depth, we have a value 6, it is already created. So we move on this side. This 1 depth, this is 2 depth, so this is null. So we just gonna create 6, and after 2 depth we have a value 6. Now after 2 depth we have a value 7. So we have a value 7, and that's it. So this will work, but in the third test case it will create an issue. So let's suppose we have given a string this. So what is the third test case? Here this test case, second test case. In this second test case, it will create an issue. So let me first copy it. So we have given this string, this is the pre-order, and we need to create pre-order, and we need to create a tree. This is the expected output. So let's create it. So we have given a root node. Okay, then after one depth we have a value 2, after one depth we have a value 2, after 2 depth we have a value 3. Okay, after 3 depth we have a value 4. Okay, then after one depth we have a value 5. Okay, after 2 depth we have a value 6, after 2 depth we have a value 6 but is already created, we have value 6. After 3 depth we have a value 7, 1 2 3, we have a value 7. So left side is created, we're gonna create right side. So we have created this tree, but this is incorrect, and according to description there is only one example, one answer. This is the answer. So we have created a wrong tree, so how we gonna create a correct tree? So let's find out one thing. So first we have a root node, then we have one, after one depth we have a node, after two depth we have a node, after three depth we have a node, then we have one depth, then we have two depth, after that we have a two depth. This is the case, this is on the right side. After two depth, after the one depth we have a two depth node, so this is on the right side. So this is 6, this 6 should be next to 5, should be next to 5. So on the left side this value should be here. So how we gonna make sure that this node will be on the correct side? So we need to store it. So first we have a 2, we have a 5. If there is any right side it will be before 5, if there is any left, this is the right, this is the left side, and if there is any right side it will be after 2 but before 5, right, in between here. But this is not the case in this example. So how we gonna make sure that this 6 will be on the other side, and this 6 is on the um, is a child of 5? So we gonna use stack. How stack will be helpful? So we gonna implement stack. We gonna store the level, we gonna store the level. So first of all check, first of all find your root node. Okay, I have found my root node. Then this, then after one depth we have a value 2, after one depth stack size is only 1. So topmost node will be the latest parent, yes. And this node means depth is equal to 1, value is equal to 1, value is equal to 2. So after one depth stack contains the latest depth, stack contains the latest node. So stack size is equal to the depth, yes. So we're gonna just create the node and add it here. This is 1 dash 2, then we have 2 dashes and a value is 3. So stack contains 2 nodes, so 2 is the latest node, and it means depth 2. After 2 depth we need to add a node with value 3. So 2 values already, 2 values, 2 nodes is already stored in our stack. So this is the latest parent, top value is the latest parent. So if its left is empty, we need to first store it in its left. Okay, its left is empty, then store the latest node. So stack contains our path and contains the latest value, contains the latest node. So we have iterated till here. Then the next is depth 3, value 3. Stack contains 3 nodes, and we are on to the latest node. This is the latest node. So if this top left is null, so the current value, which is 4, will be on the left side because left is not already filled. So we first need to fill the left. So then store it, create this node and add it here also. So this will specify the path. So after adding 4, what we have? We have 1 and value 5, but it is on to the fourth depth. It is on to the fourth depth. We only need one depth. We only need one depth. So we need to remove some nodes. So we will remove it, we will remove it, we will remove it. Now on this stage it contains one depth node. So fifth is only one depth. Stack contains the one depth. So then we need to check, is left already filled? Yes, left is already filled. So 5 will be on the right side. Yes, and fill this path. Okay, I have filled this path. Next is 2 depth 2 value 6. So it contains latest node. 5 left is empty, so 6 will be on the left side. Then the next thing is depth 3 value 7, and I forgot to add 6 here. Then it contains 3 nodes, so 6 left is empty, so we need to create 7 on the left side. So this is my output. This is the correct output. Let's do the same thing here, so you will get a better understanding. So first we have root node, so I have created root node. Then after one depth we have a value 2. So stack contains only 1, so this is the latest. This is the latest node, and depth is equal to size, so we need to create 2. 2 is means one left is not already filled. Then 3 depth 2 value 3, depth 2, and I forgot to add 2 here, and I forgot to add 2 in the stack. So stack size is equal to 2, and we need to be positioned on depth 2, on depth 2. So it contains 2 nodes. It contains 2 nodes. We are on to the correct path. So we need to check, is 2 left already filled? No. So just fill it, and go ahead. Then 4 depth 2 value 4, depth 2 value 4. Stack contains 3 nodes. We are on to the third level. We need to be on the second level. So remove one node. Okay. Now we are on to the second level. So this is the second level. We need to be on the second level. Then it needs to add 4. So is 2 left already filled? Yes. Then 4 will be on 2's left. Okay. So we have 4. Then the next is 1 5, depth 1 value 5, but we are on to the third node. We are on to the third level. We are on to the third level, but we need to be positioned on one level. So remove 2 nodes and then check, topmost node is 1. Is 1 left already filled? Yes. So 5 will be on one's left, one's right, sorry. So add it. Next is 6, depth 2 value 6. Yes. So we need to be positioned on value 2. It contains 2 values, so add 6, add 6. Then the next thing is this level 2 depth 2 value 7, but we are on to the third level. We are on to 6. We are on to the third level. So to go back, we need to just remove one value. So we will remove one value. Then we are remove one value. We are one position back. We are on to 5. So we need to be on the second level. It contains 2 values. Value needs to be add 7. Is 2 right left already filled? Yes. So 7 will be on 2's right, 7, and that's it. So we will just return root node. This is our answer. So we're gonna implement this approach. Let's code this. So first of all, we need a stack of data type tree node, stack, then I and n, calculate root value is current character a digit, and traversal dot current character is this a digit. So if this is a digit, so calculate the value. What is the value? So value multiply 10 plus get a current value. So after calculating the value, we know the root value. So create root node. So this will be my root node value, and add it onto the stack also. So root, then for other nodes. So first find the depth. Depth is 0 initially, is less than n, and traversal dot ith character is equal to dash. Then depth will increment, I needs to be also increment. After finding the depth, find the value. What will be the node value? So I can just copy paste this loop. So after finding the value, just create a temporary node with current value. Then we need to add it. So while stack is no stack size is greater than depth, so we need to remove some values to be on a correct level, to be on a correct position. So remove some values. Now we are on a correct position. If stack left, so latest node left is already is empty, is null. So value needs to be positioned on left side first. On left side first. Else if left is already filled but right is empty, so right needs to be filled. And don't forget to push the current node onto the stack, so stack will specify our path. And that's it. I hope it will work. And it is giving me TLE because I am not incrementing I. Here also I am not incrementing I. And now it should work. Yes, let's submit it. Yes, successfully submitted. Now let's talk about time and space complexity. What is the time complexity? So we are visiting traversal string, so it will be order of n. What is the space complexity? So we have a stack. For stack it will be order of height plus we are creating a separate tree, so it will be order of n, not order of n, but not order of n because n is the traversal dot length, and traversal length also contains dashes. We are not including dashes in our stack. We are only including values. So it is less than n, but we can say it is time complexity order of n, space complexity is also order of n. And that's it. I hope you all learned something new. Give this video a thumbs up, subscribe to this channel, and thank you all for watching this video.